Scott joined Stiles Machinery as a panel salesperson over 30 years ago, and we are happy to have him leading our digital solutions area, where his vast knowledge on Euro cabinet construction, production planning, and technology really shines. Scott, welcome.
Tamika, thank you. Appreciate the introduction. And I want to introduce Alec Langridge. Alec is one of our product specialists with expertise in our order entry and customer relations area, and he'll be helping me out a little bit today. Tamika's right that we really do like to have you guys with us in the presentations, be able to show the technology in the machine. And we're going to work hard today to use this time to create value for you and hopefully give you some ideas and thoughts that you can take back to your companies, to your businesses to go forward with. So with that, let's try to get started here. And let's start out with what are some of the demands of today's industry? What are some of the challenges that we face? And a recent headline from the New York Times, Made Your Way, How to Get Comfortable with Furniture and Customization. The idea of this article was that more companies are offering e-commerce, speedy customization for all at a cost-effective method. And I believe our industries, furniture, case goods, office hospitality, healthcare, education, and kitchens should all be aware of these trends and how do they affect us? Can we take advantage of this? Think about what we do and the multitude of choices that we offer our customers, and our customers want it their way. And again, common complaint is that our customers have an unrealistic view of lead times, email communication, Amazon Prime same-day delivery, FedExpress are just a few of the societal trends that help foster this, we want it now. Many of you might have started your business as a hobby, but today you are most likely investing your time, intellect, sweat, and sacrifice so you can earn a living, and that living equals money. Money allows you to pay for your family members. And when I say family members, I mean your employees, to buy materials, and most importantly, to feed you and your family, your immediate family. Is there a signal solution to meet these demands? And I know there's not, but we'll talk about a couple of things in the manufacturing and production area. Now, when we think about production, what comes to mind? I've made a big hint here, right? The idea of the Henry Ford example of the assembly line, extremely efficient production at the best cost. And how does that apply in our world, especially with the demands today? We're going to focus today on batch flow. And some of the manufacturing methods that we see in today's world are large batch flow, small batch, and then the buzzword is one-piece flow as well. And where does that fit in today? We only have a limited period of time, which means we're going to take a lot of thoughts and information, and we're just going to be scratching the surface, but hopefully we can challenge you with some ideas. Large batch flow, we sometimes think more is better, and I'm not one to challenge that, but the demands of our customers limit the amount of a lot of the same part opportunities that we used to have. This style of production is defined as continuous production of items in a series of steps, that all steps are performed concurrently. What this means is I do all of a part in step 1, then move it to step 2, then move it to step 3. Small batch is very similar, but the difference here, instead of a part moving from step to step, I'm moving all the parts for the batch through from step to step. Now this allows for a little bit more customization. It's easy to track the parts. You still have a great division of labor, but the scale is definitely different. And then one-piece flow is a method of production that moves a product along the stages of manufacturing production. And it moves along those stages once that piece is complete. In other words, I touch it, I move it. I touch it, I move it. I touch it, I move it. Now, when you think about the mass production in that Henry Ford assembly line, keep that picture in the back of your mind. What Henry Ford had was a great feeder system to that assembly line. And we're going to take a look at how that feeder system works in today's production and how we work with it. And let's take a look at how it relates to panel processing in our factories today. So I talked about Alec. Well, I'm going to reintroduce him today. And Alec is the owner of my shop. And we'll be using him as an example. He has a lot of questions.
Thanks, Scott. So what is the difference between small batch flow and one-piece flow? Should I implement a one-piece flow in my solution? Is there a hybrid solution? What is the best for me? What about my business? When do I make money?
Boy, Alec, those are all great questions. And hopefully by the time we're done with this presentation, we can answer a lot of those for you. So this illustration right here is one that James Swanson, one of our CNC specialists, shared with me off of the internet. And this really highlights for us the advantages of the one-piece flow. You can see that, again, as the large piece flow, all pieces of the batch move from process 1, and when they're all done, they move to process 2. When they're all done, they move to process 3. Same thing. In the batch, it's just a smaller number of pieces move. All the pieces move one step at a time. And in the one-piece flow, all the pieces moved as it was touched. Next one, next one, next one. And you can see the efficiencies of that highly illuminated here. But I'm focusing on the small batch flow here. Why would I do that? Doesn't this illustrate for me the one-piece flow is better? Well, the answer to me is really pretty easy. Our materials, machines, software, and customers require some sort of a batch. How often do we get an order for just a cabinet? It's usually a kitchen, a room, an elevation, or a project. But we can mix the styles to get a more efficient, cost-effective method. And this is where we talk about the hybrid that Alec asked that question about. Now, our example today is a case goods manufacturing operation. We're making melamine cabinets. They could be used in kitchens, laboratory, healthcare, AWI style projects could be used in a variety of areas. And the process that we go through is really pretty simple, right? I have to get a customer design, an order, materials. I have to have the data to produce it. I have to produce it, and then I have, make the parts. I have to assemble it together. But guess what? All this is really what our processes look like. And this is actually a data flow map, a diagram of all the information points along the manufacturing process for a cut band bore style operation. And it's pretty amazing when you think about it. We have to get a customer's order. We have to confirm it. We have to have flexibility in our manufacturing, which means we have to have data on the shop floor. And then we have to have that mindset to be able to answer all those questions along the way. And we want to make sure, as the graphic on the upper right-hand corner up here points out, that we want to make sure that, that we're making things along the way. But let's get back to the simple aspect. We have customer design and customer order. Now, you remember Alec. Alec is going to go ahead and he's going to help us understand a more modern method of getting an order. Let me get him. I got to get my laser turned off here. Make sure I don't lose my presentation.
Thanks, Scott.
All right. Go ahead, Alec.
Perfect. Good to go. Now, Scott started this presentation talking about customization. In today's world, our society is dominated by custom this, custom that, and ordering everything online. From customizing a car, which is one of my favorites, to designing a pair of shoes, customers definitely don't order the way that they used to in the past. So why not bring that to our industry? Why not have a solution that can configure what we make or sell, from couches to cabinets or even concert stages? What you've been seeing here is the start of creating a typical job inside the Configurator 3D product platform. The Configurator 3D is built off a graphic engine. So if you haven't already, you'll notice it is much different than most systems used in our industry. Using a configure to order solution such as Configurator 3D, you can create rooms by placing pre-existing products or design with parametrics. So essentially making items fit your space. It also gives you the opportunity to modify color selections and quick variations like hardware or door selections, for example. The flexibility and customizability of the Configurator 3D allows for you to create the design specific to your end user while virtually walking through the job as if you had it as a mock-up or store display. Here's what the configurator can do. Realistic and accurate 3D renderings differentiate you from your competition, with the 3D renderings helping you your close rates increase substantially. A recent study showed that there was 40% higher conversion for close rates and 30% improvement in average sales prices when using 3D models instead of 2D static images. Now, we were just showing some of the tools available today to you, but whether you have VR goggles and want fully immersed virtual reality, mixed reality with an actual picture of your design environment, a shareable 3D design link, or anything in between, really, we can help you. These tools help you get more business quicker while giving your customer the opportunity to almost touch and smell their dream designs. Now, it gives you time to spend more time for what you enjoy most. Accurate renderings also mean perfect order performance. With the Configurator 3D, you are delivering complete, accurate information about the order, not only for the factory floor, but for that end customer as well. More about that in a few moments. We pointed out that many people are shopping online today, and with the stay-at-home order due to the coronavirus, a 3D web-based system is even more essential, honestly. This seamless product platform for online web design and sales tools is a solution. This same platform has solutions for franchise, dealer, or design networks to connect to you right to that designer. Configurator 3D is a scalable solution to drive your business of today while preparing for your business of the future. Now, while we continue to show the graphical design features and processes, we'll now get into the manufacturing data. So in the background, we have a full back-end solution with all the machining and necessary information for your factory floor. This gives you opportunity for custom printouts for both external and internal use, as well as live price lists and quotations as designs change. You can easily look through the pricing structure and bill of materials, as well as remake part information on the shop floor, being that it's one of the harder things to do in today's shops. The configurator makes this easy for those times that your edge bander guy accidentally drops a panel and it gets damaged. Now, Scott, are we making any money yet?
Well, Alec, thank you. I think we're getting close, but what about the machining information? Is it brand specific?
No, and I love that question. So the Configurator 3 is completely as an agnostic solution. So we can connect to any machine as long as it has data feedback on it.
So I have additional softwares like ERP and CRMs and MES systems. What about working with those?
So this being a flexible product-oriented software, we actually, we welcome those connections to other software. We want to ensure a total solution for you as the end customer.
So Alec, I've got this 3D visual, this 3D graphic. What do I do with it?
So I'm actually going to send a 3D link that anybody here, I'm going to send it right on the chat that everybody can go and actually click into, and you're going to feel yourself being immersed into this situation. Now, from what Scott said, he's asking me, why? Well, honestly, I've had enough of people asking, this is not what I ordered. I did a different color, a different layout, and this is something that I can give them and say, hey, this is exactly what you're getting. And I usually give this right with the confirmation order with, yes, hey, this is the product that I want. This is the kitchen or the area that I want, and we're good to go, and we're all on the same page.
Alec, I really appreciate it. That's, again, a much more modern method of getting the information from the customer design to the customer order and making sure that we get all that together. Alec, again, thank you for that.
Absolutely.
So as I mentioned, we've simplified the process. Now we have to go from that customer order to our data and materials and into our production, our supply chain. And the supply chain is what our factory is, and we'll talk more about that. So remember, we're going to take this elevation, and we're now going to have to create this elevation into our system. what do we need for that? And how do we get all that information in? So we now are working with our ControllerMES. So our Configurator 3D product has sent data, sent the information, the pictures, the parts, and all that information to the MES. ControllerMES then is going to take that data, it's going to double check and make sure that we have all the data we need. It's going to look at the parts and make sure all the edge banding information is there. It's going to give us the barcodes that we need to produce. It's going to make sure that the edge bander data generation for the automated edge bander is available, and make sure all the CNC machines have the right data at the time we need it. It's going to give me tools to plan my production order and flexible creation of batches, and give me the ability to check my capacity so I don't overplan or underplan my factory. It also allows me to monitor where those jobs are at, gives me availability of all the information that I might need to manage my shop, my factory, my company, with also additional information for flexible solutions for sorting, buffering, assembly, and importantly, paperless production, automated rework channels, reduction of non-value-added activities, and production logistics. Man, it does a lot for me. Now, you guys do that on a daily basis. Do you have an MES system? No, but an MES system can handle this faster, easier, better. This screen is just an example of some of the batches that we get in the MES. So the configurator's created a job, we've created a batch now, and I can take that batch and drop it into a day, and it'll automatically create a production day based upon the delivery schedule, or I can drop my batches in based upon any other type of criteria. In this case, it was delivery days. And it looks like on today, the jobs that I have scheduled, I'm great in my cutting solution. I'm less than 60%. I'm gonna go back to my laser pointer here. And you can see here, 60% cutting. On my edge bander, again, I'm under that 60% number, but on my drilling solution, I've pushed the capacity of that drilling solution. So even though I might have that visualization that I can cut all this, I have to be aware of where I'm at in my production style and what I can and can't do. Now, how does I understand what a machine can do on a daily basis? Is there automatic feedback? Is it taking artificial intelligence? Is it doing a lot of other stuff? What we've actually used is our machine monitoring reporting system in the background. And machine monitoring reporting, each machine produces a lot of data, and each factory uses equipment in different ways. And this is not to say they're using a drill as a router, but that the operator, mix of parts, tooling that you use, and handling in each company puts a different load and therefore output of a machine. As you heard from Tamika, in my previous life, I was a saw expert. And I could tell you within seconds how long it would take to cut a sheet or stack of sheets. And I could project the output on a daily basis. But you never believe it. Often my projections were not realistic. All of those other items, the handling, the operators and things like that, which we have little control over, dictated the output. And many times I would be able to go back and work with my customers to help improve the output. But now with MMR, you have the data where you can see these things for yourself. You can understand on a historical basis what is realistic number of parts you can achieve and set those limits now in your MES system so you can plan realistically what your factory will do. This is just a quick screen which shows me this is on a daily basis, and this is a random sample of time on a machine. How much is in production? How much is the technical fault? How much is idle time? And how much is secondary usage? Secondary usage might be considered in this type of machine handling or changeover. And I also have the ability, like I say, this is a screen called a Pareto chart, and it tells me if I improve my handling and my idle time, I can improve my productivity substantial amount. So my usage, I'm getting good on my right-hand table. I could probably use my left-hand table a little bit more too, and maybe get some more production. So now I have actionable data, not emotion, to help improve my productivity, which then I can feed back into my MES system and have a better style of system, or have more production planning and better production output. Now we've got our data from the office, and with that data, we know how much material we need and things like that. So now we need to get to production. And this is the point where it's usually a lot more fun making this presentation, because you can see all these cool machines in operation, and you can see the part flow and see the operations actually happening. but I have to do it on a screen. So our operations are cut, band, and bore. And this is the layout of our process, of our system right here. And this is a system. But why is this layout? Is it right? And why did we lay it out this way? Well, the first thing we did, and when we looked at the layout and the type of machinery we're going to balance in there, is we used the goal. Book's been around for about 25 years, and its main focus is on the theory constraints. And the theory of constraints is stating basically that you have to work to your bottleneck. And so we were able to use those theories to figure out the balance and the load between each machine. Now, this is the space in our showroom, so where our factory is laid out. And you can see, if I remember right, it's about 30,000 or more square feet. But I have problems there. I've got a lot of it taken up by storage and classrooms. I've got shipping and receiving. I've got walls in place. I've got columns I have to work around, and I have material flow areas that I can't block off to be able to get through. So these are some of the ideas of facilities dedicated by shape, space, and machine design. So that's some of the ideas how we got to the layout that we're at to be able to work with it. And that's actually what we're going to be looking at, is that space right there. And in that space, we've got our material storage, our cutting, edge banding, boring, inserting, assembly, shipping, and this area here could be utilized for product storage and things like that. And if I look from one side to the other and from here to here, it's roughly 80 by 100 in space. So when you think about that and look at the amount of space that we have, it's roughly 10,000, less than 10,000 square feet to be able to produce what this system is planned for. And this system is planned for about 160 cabinets of cases a day based upon the designs that we looked at. Now, how many of you, when you start to introduce a job into the factory floor, that you have to produce a bunch of reports, paperwork, bill of materials, optimization patterns for the saw operator or for the nested base machine operator, things like that, before you can even send the job down to the floor? In our system, we use our MES. It created all that data. And in this case, you can see it has the cutting plans in here. So it's worked with our Rite Optimization system. It's optimized my batch, and this batch has met a certain limit of yield. So the green here is how much that we're using. The orange is the waste. And I've met it. I'm at 92%. Pass that along. It's okay. Let's go to production. So by working with our Rite system and the MES balancing that, it's automated that. Now, if it didn't meet a certain limit of our yield, it could kick it back to me, and I could then affect my batches by maybe combining two jobs together, mixing a couple of different parts into it, things like that, to help drive my yield to get to the yield that I need. Now, this is an example of the actual manufacturing floor. And so this was my material storage area back here in the IntelliStore. And remember, we talked about our theory constraints and we need flexibility. So you can see right now, we're cutting a sheet of material that just didn't fed white. And this is starting from dead stop. So we just started the morning. There was nothing in production yet. We've just started out. And so the first sheet is starting to come through. And now you can see the storage system, a robot, 3-axis robot, is going back, and it's feeding and bringing in material. And guess what it's doing? It's feeding another robot. And if you look carefully on the screen, you can see that the next sheet of material that is getting ready to set down right now is a completely different sheet. It's a different color of material. So our constraint of changeovers of batch size and things like that is highly not the limiting factor anymore. Many companies make decisions on the material handling of material coming into the system for the batch sizes, for how much they want to produce for the changeovers. And in our system, we don't have any limits that way. Now, what are some of the ROIs for using a storage system like this, the SawTeQ? You minimize the damage of material. I had one customer said 300% less handling of the material. Effective methods of off-fault and inventory control. You know what it is, where it's at, when it was brought in, and how to do that. And why do we use the robot on the outside? Why did I pick this style of equipment to bring it out? Is for that pulse, that pace, that consistency of output that the robotic system offers us. Now remember, I want to build 160 cases a day. That's roughly 160 sheets. And this system will balance that out based upon the mix and studies we've done, because we can simulate those things ahead of time. And you'll notice right here too, there was a device there moving. That was a label printer, and that's applying the label to those sheets. And we'll talk more about labeling in a minute. Now in that picture, there was a couple of destacking stations out here, and we weren't running those right now. The parts were moving out to the front side of the system where people were moving the parts out, and we'll see a little bit more of that detail later. And what's really interesting about this is this allows me to run the system before my shift, during lunches, at break times, without anybody at the machine. And what it's doing is it will automatically stack to those lift positions, and it's creating a chaotic stack. So you can see here it's kind of setting some parts aside, and it's laying them down and interweaving those parts. So I now have a stack that I can move on to another area without worried about them falling over. Many robotic systems only stack center to center justification. And so if I was doing different size parts such as this pallet, there's no way I could move it afterwards. And then we talked also about the label printing. So the label, the letters here represent the path these parts are going to take. You can see I now have all the information I need on it, and this barcode here ties this label, this part information, this piece that this label goes on, to all that other data that we have. So that's a critical part. And not only that, by automatically applying the labels, we get the exact orientation. So I know the grain direction. So even if it was a cross-grained part, it's not going to be put on the next machines incorrect. Now, what you can't see in this is waste removal. So that saw is cutting pieces, dropping things down. And instead of having to stop that machine occasionally or stop any of the other machines, I have a grinder which automatically empties that saw, grinds the pieces up, and puts it in my dust collector. Now, some of these options that we talk about are not inexpensive, but the payback from reduced handling, from keeping the parts running through, things like that, make it well worth the cost and the application. Now, this is the view outside the front of the machines. And we're taking a batch, and now we're taking that batch. Remember, we talked about the sheet sizes, and we had to have a batch to get started with? We're taking that batch now, and we're going to be breaking it down. So you can see that we've transitioned from a yellow sheet to the white sheet. And you notice in front of the edge bander, there's not a big stack of material there, right? And as the part is finished, you can see Gil, one of our operators there, taking the part away. So as that part is being finished, remember that one piece flow, it's moved along. It's handled once, and it moves through the system. Now, this also requires flexibility. Remember, we talked about that. John Ridgway in an earlier presentation today showed a video of edge bander running. And again, it was exciting. It was like watching, paint dry, because you don't see what's happening. And same thing with this edge bander, right? This edge bander is doing multiple changeovers. It is doing unique contour trim routes, trims on the side. It's doing straight trims sometimes, and it's doing all that stuff without anybody opening a hood or any other changes. And as you can see back here, this is 6 different coils of tape. So you remember, I've seen blue through this system already. I've got white, I've got yellow in there, and nothing's been changing. So the other part is the screen gives visualization, so we know the right orientation of the part. And you can see I've got yellow in there now and white in the edge bander right now at the same time. So you can see that the flexibility of the system and the changeover. And what you're missing right here is what's going on right there at that point. That's a barcode scanner up there. And that, remember that we put barcodes on these parts here? All he has to do is pass it under that scanner, and it's telling that edge bander exactly what to do. And that edge bander is changing the gap, and you can see it just keeps running. And that's a critical part. Now, when we have all those tape changes, MES is also telling me the colors I need in there, because I can tell you in a day or a week, 6 colors is not enough. I'm going to have to make changes. So one of our digital assistants through our Tapio web store and through our Stiles parts department is our edge banding rack. Utilizing the HOMAG Cube, which is a cloud-based application, this tracks my edge banding. Now, why is this important? Besides the aspect, if you look at your edge banding and how chaotic the stacks are and things like that. Today, we have AirTech edge banding. We have PUR edge banding, we have EVA type edge banding. And the color on the face of it looks exactly the same. But if I try to put my EVA tape into my AirTech, I'm going to have a problem. And it's very difficult to tell the difference. But with a part identification, a light stack here that tells me what rack to pull, a box with the label on it telling me exactly which one is correct, I make sure I get the right edge banding to the right machine at the right time. It also tells me how much I have. Do I have enough edge banding to do the job? Where is it at? Saves a lot of time and a lot of steps. And I mentioned that light stack, or the scanner stack above the edge bander. It could be run with a hand scanner like this, but just imagine trying to feed parts into an edge bander and picking up that hand scanner every time. Again, an automatic scanner is not inexpensive, but boy, does it really help you move parts through in a flexible system and keeping your part count up. I talked about MES and some of the information it provides for me. It's pretty exciting here that I can see exactly what jobs where in my manufacturing operation, how far along it is in the production sequence and things like that through the reports and the dashboards that I have available to me. And these dashboards can be put up in multiple places at different machines at different stations, and they can be tailored to that station if needed. Now, we talked about that capacity and that matching machines. And this is not one of the machines in my, well, this is a machine in my cell, but it has a couple extra options on it. And this is a comb feeder and stacker on this one. This is the outfeed section, and you can see there's different size parts in there. And so this is from my DRILLTEQ 8600, one of the machines in my system. And it has very fast changeover. It can change from one part size to another one on the fly. And then it, and unfortunately, I didn't have a good section of video, but this one here really shows that capability. So really what that machine looks like in my cell is this right here. So I have a person that scans the barcode, feeds it in, okay, so that's the placement area. It processes in here, and the processing is 2 parts at one time if that's available to us, or 1 part at a time, or 1 part with both sides, things like that. And then I have my removal area. And again, the flexibility and the pace of this machine allows me to keep up with the productivity that I'm looking for on a daily basis. The last machine we have in our lineup is our DRILLTEQ D200, which is our dowel and inserting machine. And this is, you can see, man, I've got this robot back here and a robot up here and this big edge bander and this big drilling machine here. And then I get to this one right here. And guess what? This machine here does the most work of any of those machines. If you think about it, a cabinet needs about 11 parts. So I need to cut 11 pieces per cabinet. On my edge bander, I might edge band 18 edges in a cabinet. On my drilling machine, I might drill 4 of the parts for those 10 for that cabinet. But a lot more pieces get dowels in them. And in fact, I need anywhere from 24 to 36 dowels on a standard base cabinet or wall cabinet, depending upon what it is. And what you just saw was Gil feeding 1 part, scanning the next part, so very fast changeover. And again, when he was done with the part, he stacked it. Now there's a little batch there just because of the pace of the machines and where the equipment is and the handling and things like that. But you can see the efficiency of the system. So now our supply chain is just about complete, right? We've had our material, we've cut it, we've edge banded it, we've drilled it, we've inserted it. The parts are now flowing down this area. But have we made any money yet? At this point, I would say we have not. So we've done the customer design, order, data materials, and now we get to assembly. When we think about assembly, boy, isn't this exciting? This is what we all want to have. A lot of cabinets going down an assembly belt, everything being done to it. But at the pace we're producing, this is the Stiles assembly area. Again, it was designed for the space we had, the constraints and things like that, and also the number of cabinets I need to build today. So in the Stiles assembly area, I have my parts coming down. And the first thing I have to do is prepare them and consolidate them and sort them. So my MES system, as I scan that label, it's telling me where those parts need to be consolidated to so I can put together the parts to build a product. Again, in this case, we're building cases, but it could be any style of product that I need a series of parts to put together on. And the screen up here is telling me where to put the piece at. So he's just scanned it. The red one is where it's going to go. And I actually have LED lights on here that light up too and highlight which one of these slots basically that I need to put the part in. And when that part is ready to build, it's green. And if it's green, it's okay to pull those parts and build it. And when I pull those parts, I take it to my hardware table. And now I have all my hardwares, my hinge plates, my hinges, things like that. I need all my tools I need to build that or to hardware that piece before I put it on my assembly table. And this screen up here is giving me the information on what hardware I need. It's telling me what type of meta box, what type of clip, what type of drawer slide do I need. And I can even put a rack in front of that and light that rack up. So I pull the right drawer slide, the left one, the right one, in the order I need. So I can do a lot with my MES system to help improve the throughput of my system. Now we're using dowels for assembly. And again, there's my hardware table. Here's my table for, here's my hardware table. Here's my assembly table. And so you can see how few steps there are in between there. So I have one guy who's kitting, hardwaring, and pre-staging for my assembly. And we're using dowels to put these together with. And in doweling, we have a glue pot that is applying the glue. So I'm using pre-glue dowels for my D200. And you can see the nozzle's not like my normal ketchup bottle, but it's making sure I coat the sides of that hole, because that's really what's important. I don't want a bunch of glue in the end. I want to coat the sides of that hole. And then we actually lock our backs in place with a hot melt system. So then after I assemble the cabinet, I press it to make sure it's square, to make sure it's tight, to make sure all those joints are in good shape. And then I take it out and I need to put my doors and drawers on it. Well, remember I talked about not pulling a cabinet until it was ready to go? And one of my pet peeves is walking through a shop and seeing cabinets that are assembled but not done yet, or not hardware. You know, they're just sitting there. There's no doors, there's no drawers. And it's because we assembled them before that stuff was ready, which means I'm gonna have to handle again, extra handling, waste, space, all those things. Well, my other rack won't tell me to assemble it until this rack has the doors and drawers and door and drawer fronts in it, ready to go. So I have my same kitting system here, and it's tied back into my other one. And this also is telling me the information I need to handle that. So now we've taken care of our assembly, and we're ready for shipping. Now we can make money. So hopefully I've demonstrated for you that a mix between our one-piece flow and our batch flow can work together to help improve our productivity and our throughput. And remember, our example today was based on 160 cabinets a day. I have customers utilizing this system on as few as 40 and 50 cabinets a day, and as high as 1,200, 1,500 cabinets per day, per shift per day in small batch production and one-piece flow style cells. What are some of the other reasons that, and some other of the cases for this batch size? Well, space and facility. I mentioned that we're doing this in about 8,500 square feet. I've had a customer that was working 100,000 square feet, large batches, and he was able to go to multiple small work cells and reduce the space in half. Another customer took out 600 foot of lineal conveyor that he was using in his batch production for work in process, transfer carts, things like that, took out 30% of his floor space. Floor space is dollars. Work in process. How many times do we, if you look out on your floors today, do you see parts sitting there? And if they're sitting there, are they making you money? We improved your cash flow because from the time we start production to the time you can deliver to your customer is reduced, which means you have less cash tied up, ready to go. And when I say less skilled labor, because we're delivering the data we need at each station, just like at the hardware assembly, we showed them what hardwares were. They don't have to have that tribal knowledge. We put those parts together utilizing a light and a information system so the end user doesn't have to have that skill set to understand what those pieces belong to, and he doesn't have to have a tape measure. Those are the types of items when I talk about less skill required. Not that they don't have to be good at putting things together and have good skill sets to handle drills and run machinery. Identification of engineering errors. I had a customer once tell me on a panel saw, I asked him at a trade show, how do you saw treat? He says, I hate it, Scott. I said, why? He says, guy made a mistake on my saw and I had 1,000 parts before I knew I had any wrong, because he was doing that large batch. Imagine if he cut that, moved it through and got it down to the assembly point and he only had 20 more pieces behind it. instead of 1,000 sitting there on a pallet. Rework information is also much easier to find with the information processed. And that rework is usually a lot less because we have good handling, good information flow, and we know what we're doing in each space. And I can balance my customers' requirements. Everybody wants it all now, but they don't necessarily have to have it all right now. They just have to have enough to keep all their jobs busy. So I can piecemeal and deliver to multiple customers on a daily basis, balancing my customers' needs and my needs to keep my lead times. And it allows me to have flexible response to changes. So again, as I said, and today we've talked about a lot of different things that we could spend days, weeks, college education courses on. And I hope that you can take away a few of the parts on this.